All right, welcome back, everybody. We're gonna go ahead and jump into our algorithm for today. Last week on Friday, you guys went over single and double pointers with Francisco, and we're gonna go ahead and kind of continue that by working on that today. Today's algorithm is gonna be a LeetCode problem with Is Subsequence. So now that Francisco finally opened up that door for us, we are not going to be looking into um, LeetCode, since I know you guys don't really enjoy Code Wars. So this should be something nice to work on. This is I believe it's a fairly simple single and double pointer, so I hope we can finish it today. But essentially, we'll get down straight to it. So the problem is called Is Subsequence. We are given two strings, S and T, right? And we have to return true if S is a subsequence of T or false otherwise. So what is a subsequence? Sub meaning is kind of like a part of or like a smaller version of the bigger version, right? And sequence being in order, right? Think of like your sequence table in Postgres, how it increments in order from one to whatever, how many entries you have. All right, a subsequence of a string is a new string that is formed from the original string by deleting some, can be none, of the characters without disturbing the relative position of the remaining characters. We have a small example here where ace is a subsequence of A, B, C, D, E, right? The original string itself is the first 5 letters of our alphabet, and we have a substring of that, which is going to be ACE. Notice it is in order on the string, A followed by C and then E. While AEC is not a subsequence of this string because of the fact that E and C are not in order. We also have, I'm sorry, excuse me. We have two other examples here. We have the example 1. I am sharing this page, right? You guys can see everything? Good to go. We have a string here, AHBGDC, and the string that's passing for S is ABC. Notice how A starts, followed by B, and then C at the end of the string. Therefore, we return true. And then for example 2, this one is AXC, but notice how for one, there's no X in here. So it's not a sequence. It's not even a part of the string. Therefore, we return false. We also have our constraints here where we can be assured that the length of S will be greater or equal to 0, right? So 0 will never be less than whatever the length of S is. Therefore, we can also, uh, take into consideration that it's probably going to give us an empty string because it is able to take in 0, right? And it's never going to exceed 100. Now, with the T string, once again, it's not going to be, always a string. We might be able to get nothing, but it would never be greater than 10 to the power of 4, which I don't know exactly what that is. But yeah, so let's go ahead and jump into this. So looking at this, first and foremost, we already know it's going to be a pointer problem. So I can come here and let's zoom in a little bit so we can see what we're doing here. For the start of this, I know that I'm going to want to declare 2 pointers. And for these pointers, pointer 1 will track the S string, and pointer 2 will track the T string. All right, so I want to make sure I can, see where I'm at with the string that I'm comparing to the big string, and these 2 pointers are going to allow us to do that. Who can see some edge cases already just by looking at this? What kind of things do we have to take into consideration?
If S if your S string is greater than your T string, then it wouldn't be a subsequence.
Yeah, that's correct, right? So we can knock out 2 birds with 1 stone, whether it's greater or if there's nothing there, right? So edge case being whether it exceeds the length of T string. So let's say S exceeds the length of T string being one edge case. Another one would be if S is equal to an empty string. So we have to essentially return true anyways, because we see that if it's none, it's still considered a substring. So we have these two edge cases here. After I identify that, I'm probably going to want to start a for loop. So start a for loop, and what I would do is maybe create a temp variable that can track uh, if I have found all the characters in my or from my S string in my T string. All right, so as I'm iterating through here, I'm checking, for example, if we're using this example here, example one, I have one pointer at A and then one pointer on A on the T string. And if I encounter the A already, I should probably maybe keep a counter like, yep, I've encountered it. And I can move my first pointer to B. I can continue with my iteration. Pointer 2 will eventually find the B. I can increase that counter to 2 and then move my first pointer to C. And then once pointer 2 reaches C, that counter is now probably equal to whatever the length of my S string is, therefore letting me know that I've encountered all three letters in subsequent order. And I can probably return true at that part, right? So maybe create a counter to track my progress. Oh, I already established that on the for loop. But essentially, once a character is found, increase my pointers and move them right. Right. So essentially, what would happen if S is equal to T, so if whatever is in index S is equal to whatever is in index T, if it's equal to it, then I can increase both pointers. If not, then I will only increase whatever the index of T is by 1. So I'll shift my right pointer and I'll keep looking until I find whatever is pointing to index I and S. Right? Does anyone have any questions before we break out into our rooms? All right. I don't have, I guess we can set up the rooms today. We have 3 teams, I believe, right?
Yeah, if you just open the breakout rooms, we'll be able to go into our own teams.
Okay. Yeah, the rooms aren't identified. Who's Boolean Fools?
Yeah, that's us. That's me, Demi,
All
and
right.
Gary.
You guys can go to room 1. Who's another team?
Project Key, just open up the breakout rooms.
We can just go to 1, 2, 3. Like team one
Okay.
goes to 1, team 2. Excellent. No,
Nice.
it's perfect, man. Great solution.
All right. It sounds like you guys were able to figure out within the time limit good stuff. Are you guys able to see my desktop leak code? All right. Well, let's go ahead and code this out. So as mentioned to you guys before we went into the breakout rooms, we are going to create 2 pointers to keep track of where we are in our iteration. We're gonna say pointer1 is equal to 0. Pointer2 is equal to 0. And I'm going to create a counter that will keep track of all the times that we have encountered the character from string S inside of string T. And all three of these will be set to 0. Afterwards, I'm going to take care of one of my edge cases, which is what happens if the string of S is empty. Well, if we get an empty string right off the bat, then there's no reason to go through the rest of the program. So we will say if the length of S is equal to 0, I want to return true. Remembering that a empty string is considered a subsequence, even if it's none. Once my edge case has been taken care of, I'm going to begin the iteration of my string by saying for I in range, and I want to iterate through the range of whatever the length of T is. All right. I want to check every single character within my T string. And in here, the first if or else statement I'm going to create is going to check if my counter is equal to the length of whatever T, not T, S, of whatever S is. All right. If counter is equal to whatever S is, that means we've encountered every single word within this string, and we can return true. All right. Now, here comes the actual work of it. We're going to say if S pointer 1 is equal to T pointer 2, then I want to increase my counter by 1. And then I want to shift both my left and my right pointer. All right. If I already encountered A right off the bat, then I no longer have to keep my pointer 1 at the first index or index 0. And I should be able to move it to the right. And then same thing with pointer 2. I should be able to move it to the right. So on top of counter, I want to move pointer 1 plus equals 1 and pointer 2 plus equals 1. Now this is if they equal the same. Well, once you get to index 1 for both S and T, we're going to encounter the fact that they don't match. So we should have a statement for that. And we'll say else. If they do not match, I need to shift pointer 2 to the right to continue iterating through string T, but pointer 1 needs to stay the same because we have not found the character B. So it should be pointer 2 plus equals 1. And then finally, we can say if counter is equal to the length of S, then I want to return true. Because what happens if it actually makes it all the way to the end of my T string, and C was the last character from S to be found? Well, it never gets to iterate again because it reached the end of it. So we never return what line 12 does. So at the end of our for loop, we have to also return it. And if it doesn't return true, then all we have to do is return false. And we can run that. And we see here that we passed test case 1 and test case 2. We can submit. And I was able to beat 32% of all the other code within LeetCode. Not too fancy, but not too bad either. Do I have any questions about Is Subsequence and how we reached this outcome?
I have a question, Roger.
Yes.
So like, if you were to find this at an interview, like if they were to come in with an interview in your head and you saw this problem, what kind of problem would you think this is? Like, what's the type of algorithm would you go for?
Well, the subsequence is kind of what gives it away, right? When I was, when you read subsequence, you're trying to find something within the string, uh, that kind of gives it away that you might want to use some type of pointer, right? And there are certain keywords when it comes to different data structures or problems that kind of give off like how you should go about a certain problem. For example, like if you're working with a sorted array, sorted arrays can be done by using like the divide and conquer methods.
Sure.
Those are very common. So the keywords in the problems is honestly what gives it away. And you can get better at that by honestly just doing more of lead code, or you can kind of just Google like certain keywords that kind of give you an idea of what algorithm to use.
It's just
Does that
something,
answer
I
your
thought
question?
of a window function like with this one, right? I thought of the window and the either slide. Here's like that's for me. I know subsequence gives it away, but subsequence to me tells me I should be using a window and looking at right the subsequence or the subarray inside the main array as a window, which is with the pointers and sliding it around. How you move the window is different, right? But it's still a window.
Yeah, I'm curious of how that would work if when we work with sliding windows, we're trying to shift it to the side. And those are typically an array that are not only are they, subsequent of each other, but they're like back to back of each other. Where you kind of create a window, it starts at one index, and then you can either increase the window or slide it over. So I'm curious of how we can do that. But that is a good question. You are right. That brings into consideration. Can I use a window on this?
And then
Go ahead.
I have a second question, which is based off of Owen's, because he's going to be too modest to actually make this comment. Owen's code is very close to this, but you say if counter equals length s, return true. Why not just leave it the one on the bottom? Because you ask it twice, and so if it's doing it twice, isn't that an extra? Like if you take the top bit off and run it, will it still pass?
Yeah, so it should still pass, right? But the difference is it'll stop the moment it encounters everything, right? So if ABC are right off the start of the string, then it'll stop there. It should still work. We can run that off because the counter will only increase whenever it actually encounters that character, and eventually it will iterate through the entire string. So you could do that, right? I did that only so we could just stop the actual for loop and just return it the moment we find it.
Yeah, well, but I mean, I'm asking, doesn't the second if counter, because you had it twice. I'm thinking of the whole dry, like don't repeat yourself. And because you had those two lines of code at the very beginning and at the very bottom, wouldn't you eliminate one of them? I don't know. Like honestly, I'm not that great at this stuff, so it's like I'm genuinely.
Yeah, I mean, that's a good question. When it comes to, if we're thinking about time complexity and space complexity, we're not essentially creating new variables. We're not taking any more space, and we're not increasing the amount of steps it's taking to happen. So it really won't make a difference when we talk about performance-wise.
Yeah, that's true. Okay.
If you want to talk about like how it looks, right? Whether it's clean, whether it's not cluttered, that might be what you take into consideration for it. Besides that, when it comes to complexity of time and space, it doesn't really make too much of a difference.
Oh, that's fair. That's fair. No, that's true.
Yeah. All right. If I have no further questions, I'm going to go ahead and stop the recording now.